some of their AI models have created so many various polymers and combinations of polymers using the chemistry methods that they're exactly like you said. They're going to be these materials that are going to come out. They're going to be custom made and ideally produced specifically for every use case you could think of. There's going to be a very specific material for it. Federal government trying to get into business and start utilizing startup mentality and startup processes and innovation to really drive the innovation forward for defense. Because one of the unfortunate realities that you see is the current modern procurement method for government. It actually stifles innovation, and it only allows certain key players to sit at that table.
Welcome to Manufacturing Insiders. Today I have Ian Ramsdell with me, and he is making some big waves, created an innovative product that allows you to 3D print electronic components inside of an assembly with a standard 3D printer, which is a challenge that is, kind of talked about widely in the space. There are some solutions that, that are out there, but this one has some benefits that really kind of blow them out of the water. This is the way of the future. He has some pre-commitments with some really, really big OEMs, Boeing, Northrop Grumman, just some really big players in the space. Welcome to Manufacturing Insiders, Ian. I'm so excited to learn about what you've come up with.
No, thank you, Nate, and just want to say thank you for having me on, and thanks for we had a pre-discussion beforehand. It was great to meet you, and I'm excited to talk about the future of manufacturing and how exciting some of this deep technology that's coming down the pipeline that you're seeing, that's groundbreaking, that's being introduced to not just the defense industry but the commercial market as well.
Yep. Yeah, and you and I both have some previous experience in the defense industry. You having been a Navy veteran and myself a Marine Corps veteran, so we connected on that. So did that experience in the Navy contribute in any way to what you're doing now?
It contributed to the perspective that when I was analyzing the technology for a commercialization aspect, about whether or not the value add was there for the long-term result. The long-term result being it's supposed to be a dual-use technology, and where we can find use cases and implementations that'll best bring this innovative pathway and ability to our warfighters, especially because, as we discovered in the process, we're going to be able to do this as a fieldable technology that they can have in country on a FOB or on another operating base.
Interesting.
And we're excited. We're excited to see that, as well as the struggle of developing those relationships and the progress to combat the bureaucracy necessary to export your technology or try to get it to the forefronts of current use cases that like, for example, the battlefield of Ukraine, which is such a you think it would be a little bit easier with innovative technology to reach out and be able to provide a solution there, but it's more complex than people realize.
Right. Yeah, and I mean, this kind of, I guess you could say, democratizes electronics 3D printing, because instead of having to have extremely complex, really expensive printers, anybody can buy this material and 3D print their designs and bring it to market.
Yeah, Nate, that's awesome statement. What you're literally described, one of the motivations behind the inventor's reasoning for why he wanted to produce this material for the United States Navy. So it was invented at a naval weapons laboratory, or a national laboratory is the appropriate way that they label these organizations. And that being said, what it is there's a vast amount of tech dollars that are R&D dollars that are going into these national labs from our tax dollars. And as a result of this, there's these awesome technologies and innovation that happens. And then the one thing the national labs don't do is they don't manufacture, spin out companies, or try to take these technologies and develop them and commercialize them in-house. That's just not the nature. That's not the value add that the national labs and the policies that fund and operate these organizations, what they're getting their value from. So what they do is there's programs of record that we all know and love, such as the the national weapons systems like the F-22, the Abrams tank system. Those ones are going to go to your traditional defense contractors initially, because what they're looking for as well is the company and the organization's ability to deliver those capabilities. As a startup, we're not going to be able to build an F-22 right out the door,
Right, right,
unless you have some of that great Silicon Valley money that you see some defense
right.
technology companies
That's what I was gonna
currently
say.
on the
You give
market.
me enough money, I'll figure it out.
Yeah, exactly. And that's what it really comes down to is the ability of the federal government trying to get into business and start utilizing startup mentality and startup processes and innovation to really drive the innovation forward for defense. Because one of the unfortunate realities that you see is the current modern procurement method for government. It actually stifles innovation, and it only allows certain key players
Right,
to sit at that table.
right,
So, like you said, democratizing innovation is actually the forefront of one of the reasons why this technology was invented. So, the technician in additive manufactured electronics, there are really only two methodologies for 3D printing electronics currently. They consider traditional electronics manufacturing a form of additive manufactured electronics. But this isn't the technology. We're talking about the groundbreaking innovation, which is allowing you to do pinpoint precision and manufacturing in not just a flat planar version, but also in the 3D version, in the Z offset, as they say. And so the two main things: one is a machine that costs anywhere from $500,000 to $1.25 million. These machines are highly specialized. They're highly complex. You need like a dedicated engineer to operate the machine because of how complex it is. You can't
right.
have like a lower level technician. Um,
Are
the
those the ones that are doing like powdered metal 3D printing, or is that
Nope,
different?
those are a completely different section of the industry.
Okay, okay,
Uh,
okay.
so we're looking at the ones that are doing silver inkjet deposition, and what they're doing is they're using like almost like a syringe needle to apply a fine mist of silver particles and laying it down in a precise fashion, and then
I
normally
see.
it has a type of resin that carries these materials, and then as part of the post processing after you finish, it cures or cooks off this resin so that then you have a contiguous um, conductive trace or print.
Right,
And then these machines are also plug and play devices. So one of the neat features of them is that they can, after you print your components, the machine will actually then put what electronic components you said to add on to it. And then it will do a solder wash or some type of other type of adhesion process to get the components to solidify to the base processes.
right,
As part of this, they're also able to implement certain types of polymers that they use in common with 3D, or excuse me, with electronics. And they're able to create these really awesome niche application microcircuits. And you can see them online from like nano dimensions. And what they're doing is fascinated, very innovative technology, but it's actually leaves a hole in the market because since they're doing niche applications, they're actually eliminating very strong use cases for high voltage and high amperage applications.
right.
So then you look at the second method of 3D printing electronics, and that's to use, we had to compare it directly to the current machine that we're operating, the standard FDM or FFF 3D printer. This is the 3D printer that you find when you Google Amazon 3D printer.
Right.
Matter of fact, we validated on 3D printers that we literally pulled up on Amazon and bought off
Okay.
Amazon as well.
Which is great. I mean, that means that
Yeah.
this can be used with pretty much anybody's device.
Exactly. So if you have a device at home, you can utilize this in some fashion. We work better with multi-material systems or multi-headed printing systems, only because the value we bring to the market is the ability to use multi-materials now in a truly not just innovative but functional process. A lot
Right,
of the multi-material systems are really kind of gimmicky when they first came out. It allowed you to print blue and green together or offset multiple colors. Or
right,
as people got more complex, they would do different materials together so you could increase structural integrity of certain components. But what it really did was the use cases were very slim and niche because not too many people needed integration of these other two polymers together. With our material, now we allow you to implement actually truly functional components integrated into these polymer structures as they're being manufactured, which
right,
has never been done before.
right. Yeah, so some of the challenges in the marketplace, from the little bit of research that I've done, is number one, the resistance of the materials. So, like the materials out there that are conductive right now that you can 3D print have a pretty high resistance. Which high is relative, but the best one that I was able to find was a 0.005 ohm per centimeter.
Yep.
Yours is 2 orders of magnitude less than that. Actually, you're looking at 0.000025
Yes.
ohms
So
per
we're
second.
that would make us 48,000% more conductive than those other polymer-based conductive filaments. And Nate, you nailed it on the head. What it is they're using polymers and plastics to try to carry conductive materials, which at the time was very innovative because what they were trying to do is utilize an existing process that was currently innovative on the market, which was you currently see this with like the marked forged printers where they cram a bunch of metal particles into a plastic. They extrude the part through traditional FDM methods. And then what they do is they put it in an oven and they sinter it at a very high temperature to try to fuse those molecules while also trying to burn out the plastic.
Right.
However, part of this process unfortunately leads to a wastage of about 20% of warpage and shrinkage of components that you print. So there is a significant amount of waste involved in this process. But one of the other things what they realized was when they try to do this with truly conductive materials, one of the materials that you would use, aluminum, is extremely dangerous to operate and interact and deal with in powdered form. So you have to have very stringent safety methods in-house to work with this. And as a result, that just drives costs through the roof.
Right.
So then what they end up doing is they end up working with other non-reactive metals like their copper metals and some others. And what they ended up doing was as a result, for some reason in these processes, SLA and other and FDM processes, copper doesn't do well with post-processing. When you print these copper components, a lot of times there's a lot of porosity involved in it, which leads to failure points and as well as reduces conductivity. Now, when you implement a plastic into this mix, what this actually does is it's actually creating as the plastics are being melted down, they're going to leave behind carbon and other waste products. That's actually going to interact with the bonding of the copper and create other conductivity issues. So the copper's components you can make with these materials are do very well, especially for some thermal applications. Like you start to see some rocket engines and bell mounts and stuff like that being produced with this process. But as far as electrical conductivity, there's for some reason there's a lack of ability to increase and improve this process specifically for electronics. So what you'll see their use cases being used for is like really strong, like power buses that you need to put some significant voltage through. But we can also be used for certain high voltage and high amperage applications as well.
So I get that. So so some of the other challenges from what I know, which is limited, are so when you're melting, essentially just I'm going to put this in like stupid man's term. So
Yeah.
when you're melting a metal and then putting it inside of a plastic assembly, then you run the risk of you're melting into that plastic assembly while you're laying it down.
Yep.
So do you have like a special polymer that has a higher melting point that you are putting underneath this solder, I guess you could call it, while
Yep.
you're laying it in?
We are using polymers that have a similar melt temperature exactly for that reason, as well as we're avoiding other polymers. I spoke in depth with UL Labs when they realized the type of technology we were releasing, where we were embedding electronics directly into polymers. They wanted to have a safety discussion with us about certain polymers that probably aren't conducive for use with our material because of safety concerns.
Right.
One of them being, and the very primary one they want to speak to us about, being PLA, the most common and easily printable polymer in the 3D printable market. And with this, unfortunately, at the temperatures that we'd be operating at, it causes the PLA to extrude an oil that is highly combustible.
Mm.
And so now you add electronics and electricity through that mix, and it can lead to dangerous situations. So we've actually put it in our MSDS, and it's in all our documentation that we don't recommend use with our material with PLA at all.
Okay.
However, the next most easily readily available polymer on the market is PETG, which is very similar in melt temperature to us, and we've been operating quite firmly in that. But some of the for certain polymers, we actually want that slight temperature difference, because what it's doing is actually creating a chemical bond between our material and
Adhesion.
the base material, and so that's
Right.
how we get our adhesion, which is why we've been able to print flexible circuits as well.
Wow. That's cool. Yeah, so I was just thinking when you were talking, I had a conversation with the guy the other day. I'm actually going to be interviewing him on the podcast. Should be a really interesting talk. But he's using um he's got AI engineers combined with chemists, and they're developing custom polymers that have the perfect property for whatever application you're doing. And it just seemed like there's like some play together here, between what you're doing and what he's doing.
It's funny that you mentioned that, Nate, because one of the things we discussed early on was if we did have certain adhesion issues with other polymers, how could we remedy that for our end users? And one of the easiest solutions we found was actually to come up with our own polymer that would bond specifically with our material more significantly.
Yep.
And we were discussing the different chemistries available. And that actually inevitably led to a conversation I had with some people over at I think it's Penn State Applied Research Lab,
Yep.
where they were explaining that some of their AI models have created so many various polymers and combinations of polymers using the chemistry methods that they're exactly like you said. They're going to be these materials that are going to come out. They're going to be custom made and ideally produced specifically for every use case you could think of. There's going to
Right.
be a very specific material for
Right.
it.
Yeah, so eventually you're going to sell them in the same box. You're going to sell a roll of the solder conductive material with the custom polymer, at least
Eventually,
for the
yes.
part of the assembly that's directly in contact with it. But
Yep.
yeah, if you're interested, I'd be happy to make an introduction. But it would be cool
Yes.
to listen. When I interview this guy too, I think his name was David, and I think his company was called Aries Materials. But very cool synergy there. So, what do you think the future is of this? Like, when this fully gets to market, I mean, what do you think the potential is? What are people going to be using this for?
The use cases we discovered in our customer discovery were pretty significant. We had some ones that were very broad, where like we had a brief conversation with the vice chairman of Foxconn USA. As some people may not realize, Foxconn's one of the largest electronics producers in the world, if not the largest producer in the world. And
May
they're
not be the case for long.
for long, but they're most commonly known for making iPhones.
Right.
However, there's also a lot of controversy that surrounds this company. So when you're this young, you actually have to be very cautious and risk adverse to certain conversations you have with certain individuals. But very quickly in our conversation with Foxconn, we found out that they had been trying to produce a material similar to this unsuccessfully since the 90s. And as a result of that conversation, they tried to form a partnership and purchase sample material. And unfortunately, we at that point in time we were real early on in the defense DoD startup studio program we're part of, and we had no right to sell or offer any or sign any deals. So we ended up moving on through the process. This was early on, so we had 16 weeks of the program before anything happened. So, but that really showed some of the early value. So, in regards to other use cases, one of the primary values we really see us bring to the market is the ability to now embed electronics in a plastic and polymers. And the reason why this is vital is because it can't be done. There's no way to do it currently. You can use one of these really expensive machines to make micro circuits and antennas and such. But unfortunately, you're not going to be able to do anything that's significant for high voltage and high amperage applications. And we're looking at stuff like CubeSat buses, as well as other types of embedded electronic components. And we're actually even in the process of dropping. I think we have 5 grants in the pipeline for this current cycle, and we're currently in the final selection for another grant that we're waiting to see. Because one of the other things we've figured out is that we can the resolution of the material is really only restricted by the orifice of the nozzle size. And so
I
one of the
see.
other interesting things about this is the fact that while it's not zero point 0.1 mil in width, this is 0.1 0.12 mil in height, but we've printed 0.1, 0.2 mil traces out of the orifice. It's the orifice size of the nozzle on the printer that really dictates it. We've gone down as far as 0.1, which puts us in the microelectronics realm as well. So we kind of fall in a new innovative category, which we're not traditional microelectronics as they're known. But
Right.
what we want to do is utilize this to actually embed various electronic components into polymers as well.
Yep.
And so we're looking at like potential capacitors and resistors, heater blocks, heat sinks, and other types of materials because
Which
we're
once you can
all
do that, I mean, once you can do that, I mean, you're only a couple steps away from, you don't have a Foxconn anymore. When you want an
yes.
iPhone, you go and you purchase the program for it and you print it.
Yep. Yep, and even more so is it on our product development plan will be our own version of a pick and play printer that will allow you to automate add in the electronic components that can't be 3D printed, like some of the chips and other types of
Yep.
components. But more so is now imagine the way that we design current electronics. You can look at anything that we own, and you can quickly realize that they're designed around a very specific flat feature.
Mm-hmm.
And because the electronic circuit board or brain of the device is actually only produced in a flat component. And so another realm where we're going to see groundbreaking research in materials and components produced is where you're going to do non-planar electronics as well. And being able to print on curved surfaces is once again a feature we're going to bring to market that is very slimly, if not almost impossible to do currently.
Wow. It's fascinating, man. So how many years out do you think we are from like the wide use of this technology to 3D print non-planar electronics, and this is just a common part of the process?
So we're early in the industry as a whole. The additive manufactured electronics industry, I when I first started, I thought it was a little bit further along and advanced until I started digging deeper and realizing that even these very expensive machines, they're not really being used for widespread manufacturing process. They're really only in research labs and
Right.
in defense labs being
Prototyping, that
used
kind
for.
of, yeah.
Yep, very small applications, one-off applications, if not multiple applications, which is a great process. But what it doesn't lead to is it doesn't lead to OEMs eventually accepting your process and material and implementing it into it. And so what we've done is, as part of our early process with our early customers at like NASA and Northrop and KBR, is what we've discussed with them their use cases that what they want to see with our material, and we've developed and work with them bi-weekly and some weekly on these projects to one of the things we want to do is immediately validate a very small version of their product or what they're trying to do in-house.
Right.
And my production engineer Steve is really good at this. Is so like we were talking to one of our customers. They wanted coils, embedded coils, like into the plastics and polymers. And so by the time we had our meeting the next week, Steve had like, I think it was 10, 15 different electronic coils that he had 3D printed in various fashions, ready to
Wow.
show them. And he was showing them also not just the fact that we could demonstrate the technology, but think about how much output we just produced, where if they sent that out to a board factory or an electronics manufacturer, it would have taken them weeks, if not months, to get it back.
Yeah, absolutely. Yeah, it's fascinating. So, from what I understand from our previous conversation, you're kind of looking at some grants. You need to raise some money. Like, what are you raising money for right now? What do you need to develop?
So we're trying to keep it strategic in the fashion of there's public money available out there to help grow and demonstrate capabilities of technology, as well as this opens up one of the biggest pools of money available for any corporation and company to operate within, which is the Department of Defense. That we're looking at $1 trillion budget in the near future for the DoD, which is one of the. I mean, you can't even like compete in most countries for that pool of money because that's like significantly more than the country's GDP. So, as a result of that, you can be a small fish in a big pond. and end up doing quite well. And even more so, what ends up making you end up being very attractive to those large fish in that large pond when M&A and acquisitions come in, or where they realize that it's cheaper for them to do business with you by owning you than it is by
Right.
contracting you out. And
Right.
so you start seeing that as well as these technologies develop. So the sorry, I lost track of
Well, yeah, I was
what the
asking
tail end of
about
that.
you raising funding,
Yeah.
looking for
So
investors.
so the by using this pool of public monies, one of the things that's very helpful is it allows you to grow your capabilities and demonstrate your technology to these customers, as well as uh, add value to America, which is what people forget the base purpose of these programs. The reason why the government spends billions of dollars every year in grants for technologies is because inevitably these technologies are going to be for the greater good of the America as a society, as a country. And so they see it as a long-term investment into the GDP growth. This also
Mhm.
applies to the technology transfer down the process. So we going after these grants and this fundraising to develop and test the boundaries of our technology. And as well as this is going to establish these DoD customers, but at the same time, what we're trying to do is we're implement ourselves into the civilian side of things or the commercial side of business. And what raising a true fundraising round would do is a lot of people misunderstand what startups and startup fundraising, how it operates on. And one of the most simplest yet cliche explanations I've heard of it is, so the founding team and what their responsibility is to take their technology and build a rocket ship. And the rocket ship is the business model, the product development, the early sales, the partnerships, and early fundraising and technology validation. And this builds the structure of your startup, which is a rocket ship. And so when you go out and you start fundraising, what people misunderstood is they think it's just you getting a bunch of money, and that's supposed to start paying people now so that you can just drive sales. And you see a lot of startup funding go into like 50% marketing or even more just to drive sales. But what they fail to realize is what that influx of capital actually does is it's the ignition on the rocket ship that you built. It's the light that starts the rocket so that it can start climbing into the sky and becoming a large company. Because the point of venture money and investment is to accelerate your development and accelerate your growth as a company. And what you're doing is you're now offering a trade-off in exchange for that. You're giving up a portion of your company in exchange for access to this capital to accelerate your growth. And
Right.
so when you look at it in those terms, it kind of brings a different value add as it imagines. But unfortunately, as the nature of companies in early stage technology goes, the money has to come out as a shotgun approach, because you never know which technology or which company is actually going to be the most successful. The only real, way to gauge and add a metric to that is to point to entrepreneurs that have already been through the process and have succeeded before, because typically serial entrepreneurs do successful with other companies as they progress.
Right. So, so it sounds like you're kind of leaning on some federal grant programs and that type of funding. Are you also kind of looking for some private investors who might want to buy into this, and what would they be buying into?
No, that is correct. So we are looking for those private investors as well as the government grants. The government grants and partnerships, like I said, is just one side of the puzzle. The other side of the puzzle is the commercial side, which the type of money what our investors would be getting is they're getting the new growth. The market we potential of our industry is pretty significant. We're looking at a multi-$100 billion market as a whole when you look at the fact that we're market and industry agnostic. But our initial market penetrations are focused in CubeSat and in space development as well as DoD. The CubeSat market alone has approximately, I think it's over 2,200 CubeSat and pocket satellites going up in the next 3 years. These are considered consumable items. They're going to go up, and within 30 to 180 days, they're coming back down. This is going to help us drive our growth, and as well as the ability to maintain a product line and value stream with our future customers. Even more so is we're bringing a new innovative way of manufacturing, which is something, as I mentioned, that can't be done with embedded electronics. And so with our material, in our future iterations of our material, like our radiation hardness, our EMI shielding, our anti-tamper, and some of our other exotic materials that we have in the pipeline, what you're going to be able to do is you're going to be able to put this multi-layered, multi-material process. So when I say CubeSats, imagine a CubeSat frame, one side of the housing that just houses certain sensors and antennas designed specifically for that mission. And so one of the things you'll be able to do is do a multi-material, multi-layer process. You'll print some plastics or polymers. You're going to then embed the electronics or various electronic components into that device or that polymer. And then you're going to cover that in polymer. You're then going to be able to cover that in our radiation shielding material. You're going to be able to cover that in polymer, and then you're going to be able to embed a surface-mounted or embedded antenna into the last couple layers of that polymer. And what this is going to be able to do is it's going to condense everything, remove failure points, and it's really going to achieve what's a new buzzword within a lot of aerospace and space applications, which is SWAP, which stands for size, weight, and power. So we're going to be able to increase your power draw. We're going to be able to decrease your size and decrease your weight by embedding all these components into it. Even more so, we're eliminating huge failure points in the design and in integrating new technologies such as the ability to be used for power buses with our material, which can be embedded directly into the structural arm of the CubeSat.
Yeah, that's
and
amazing.
So we see that, and then our DoD applications, we're looking at using that same process just with other exotic materials for DoD specific purposes.
Yep. Yeah, and to expand on the space application too, when you're up, at the space station and you have a component failure, I would imagine the solution right now is to stock redundant products. You've got, all these extra assemblies that you have to store up there, which obviously weight is a big issue. And so now all of a sudden you have a 3D printer that can make these components on the spot on demand.
Nate, it sounds like you're talking to me about the future of NASA and what they're describing, because two things people don't realize is currently going on. The first is that the weaponization of space. We are in a Cold War space race. People just don't realize it. There's treaties in place to prevent when we're not supposed to do any weaponization of space. But what this has led to is that they're just probably outright lying about it, about them having certain capabilities in space, and B, it's turning into a race to the moon currently. We know Elon Musk wants to go to Mars, but what everybody fails to realize is there's a better launching point than the planet Earth to launch anything into space, especially going to Mars, and that's going to be from the moon. And so currently NASA's got a few very significant new missions that they're really focused on. One you're seeing is the lunar base that they're talking about. This is where they're talking about how are we going to manufacture housing and everything we need on the moon, because of the fact that it's going to be extremely expensive and cost prohibitive to ship raw materials to the moon in rockets. Elon's driving down this cost with reusable rockets, but overall it's still going to be cost prohibitive. So they're looking at how to recycle, reuse, as well as to repurpose and to mine and gather resources on the moon itself. And so one of the ways you're going to have to get to this is you're going to have to provide these ability to manufacture components from raw materials in space. And you're looking at advanced and additive manufacturing as filling that gap until they start being able to produce these materials in space. So these polymers, these electronics, and everything are still going to have to come from Earth. This is also kind of falls in line with the DoD's mission, where they're talking about space manufacturing. So to get from here to the moon and put realistic infrastructure on the moon, what you need to do is you need to build it in orbit. And then they're going to have to move it from orbit to the moon. And so what you're going to start seeing is more and more drive an initiative for what they're calling in-space manufacturing. And you're seeing some companies really coming down the pipeline with some of this. One that comes to mind is Varda Space Industries. They're doing something where only the microgravity in orbit can hold the molecular structure of their pharmaceutical in the bonds. They have to wait till that bond finishes before they can bring it back to Earth and actually have a pharmaceutical that can now be helpful to humanity here on Earth. And so you're seeing all of these crazy, unique, innovative approaches to space manufacturing. And this is going to just drive material science even further, as well as who knows what else in all reality. And then the other thing you're seeing is that NASA has a mission for extreme environments, and we're looking at the drive to put various rovers and scientific apparatuses on like Europa and some of these other ice-based planets and moons to see if, I think they're looking for signs of life, as well as to other, I'm sure, plenty of other data. I love how they can always gather so much more information than what the main mission is when they design these groundbreaking sensors onto these craft. And where Kupros really sees the value add in that is because we're going to be able to embed these electronics into the polymers, is you're going to be able to use polymers that are suitable for extreme environments. And more so because we're embedded in nature, we're going to have eliminate some of those possibilities that some electronics have with cryogenic conditions, like such as tin whiskering. Additionally, the base way we manufacture the material is we put an additive to our material to be able to change the material properties of the base tin material is what we've effectively done. So there's this wetting property that tin has when you melt it. And what we've done is by our process in our proprietary additive is we've eliminated some of that wetting property, and it actually has caused us to increase the surface tension, which allows us to extrude out of a polymer extrusion system such as an FDM printhead. So this process has also been verified in space for space manufacturing. So we're going to have the extreme environment applications where Kupros' embedded material and our additives is going to prevent tin whiskering, which is a problem. And then the ability to, like you said, print these components in space is really going to be what's going to be fantastic as the technology advances. I'm actually in the process of filling out an application for an accelerator to see if we can get our material on the space station for an experiment. So fingers crossed on that.
Yeah, that'd be some good marketing for you for sure. So if somebody's interested, and fascinated by this product like I am, and what I'm kind of thinking about too is like I have somebody else that I've been talking to. They're a printed circuit board manufacturer. And they tend to do pretty short runs. And so like, it seems to me like this is something that they should be really, really interested in. I mean, you can correct me if I'm wrong, but it seems like this is something they can start playing around with and trying to integrate, this product into their manufacturing process.
That's exactly so. So one of the things we discovered is there's a huge drive for innovative electronic solutions within aerospace, space applications, DoD, and academia. They're looking at this not just because of wanting to drive innovation into the next realm of the future, but more so because unfortunately one of the things we've discovered in recent years is that our supply chains are pretty much at the whim of a government, and it may not even be a friendly government at all times that we're dealing with. So at any point in time, they could completely cut off our access to vital technology and components we need to survive as a society. While we hope and dream that this never happens, there's a saying we both learned in the military, Nate. You can hope in one hand and you can do something else in the other.
And see which one
fills up first.
Yeah.
And, so because of that, one of the things America's been good at is being prepared. So as we look at the future, one of the things we need to look at is ways that we can sever that bond if it ever needs to happen. And one of the ways we're going to see that is these innovative electronic solutions filling that gap in traditional electronics. The current PCB manufacturers, they're getting interest in from these defense institutions as well as DoD primes for really innovative electronic solutions, but none of them supply because their capabilities are traditional electronics. So the one thing that Kupros is doing is we're not gatekeeping access to the material, or we're not designing a very exclusive machine that you have to purchase from us to access our material. You can use a desktop 3D printer to validate this. A matter of fact, my customer at Northrop, I sent him I think it was a $339 printer that we had validated in-house. I was like, I know you guys have expensive machines. You don't always have the bandwidth to get on this. So here's a free printer for you guys to have so that you guys can validate our material. Because if you can validate it on the cheapest printer in the market, then you should have no problem putting it in the most expensive machine printer in your shop and validating in that. And that's exactly what happened. Within 4 weeks, when they finally got their brand new $250,000 printer, and that team finally got their time on it. Within 2 prints, they had validated our material on that
That's
machine.
awesome. Wow. So, like, let's talk about just an average Joe, a guy like me that's interested in this,
Mhm.
wants to be involved. What kind of mechanism do you have for, an average investor, someone kind of mid wealth range that wants to, get in on a piece of the action?
No, excellent. One thing that people don't realize is that, like, I have a lot of friends and a lot of people I meet through things that they hear about a technology. And they're like, "How do I get in? Can I invest right now?" Um, People forget that startup shares in stocks are actually a financial security, and as such, you fall under the purview of the SEC. So for these, like the good friends around, unfortunately, the one time that access is open is during what's called the friends and family round. And once that closes, unfortunately, then what has to happen is people have to be an accredited investor to start applying for certain corporations. However, there are certain other leeway or other avenues of investment. We just haven't gotten interested enough to consider it. We know they have these crowdsourcing platforms for designing new technologies. Well, they also have it for investing in startups. I think WeFunder might be one. There's only a certain platform we can use because the type of company we have. But if we started getting a significant interest in where we felt that we could utilize this to raise an appropriate amount of money, it would definitely be something we'd be interested in. Otherwise, unfortunately, what we're looking at is we're currently entering our one of our formal financing rounds where we're looking at venture capital investment to move forward. So if I suddenly see a bunch of emails coming in my inbox asking for investment, then we can look at WeFunder and how that applies. But unfortunately, when you deal with real professional investors and VCs, those type of fundraising vehicles are normally a mess that has to be cleaned up after the fact. And so
Hmm.
they've sometimes it's not attractive, and I've even heard of companies being turned down for investment because they have those crowdsourcing fundings.
Right.
It also depends on the audience, the funding, other types of things.
Right.
One other way that you can support us right out the get-go is the fact that we wanted to make sure that we allowed access to our technology at the lowest financial level that we could potentially attain at the moment. And one of the ways we did that was by offering a unit of sale from our website, where if you're a hobbyist and you just want a couple meters of our material, we sell it in the 50-gram size. I think it's 250 or $250 right now for 50 grams. 50 grams gets you 50 meters of average size electronic traces, which can get you a couple electronic components or projects that you're working on done.
Yep.
This we're offering, even though it's tedious to us because you're talking about taking out small chunks of a unit that sells a lot bigger, but we wanted to give access at whatever level we could to the lowest level, even
Yeah.
though we know it's not. People think it's quite expensive. The value add is the fact of how far the material will get you on a project.
Right. Yeah. No, I think that's great. And I mean, I think there's a lot of people out there that are playing around. I mean, I know even my cousin was, he got a 3D printer and he was obsessed with it. And he wanted to invent this, I don't know if I should give the secret away, but it's like a smart cone for ice hockey. So like
Mhm.
if you're part of an ice hockey team, you're gonna have your practice session, and the coach is gonna go out there and set a bunch of cones on the ice in some sort of configuration. But basically, his idea is to have an app that controls these smart cones that just you set them on the ice and they go in whatever configuration that you have set up, and it takes a lot of the time and effort out of the whole coaching process. But at any rate, he actually, I was telling him about this conversation, and he was like, "Man, I was looking everywhere for something that would do what he said, this is doing." So I think there's probably a ton of people out there that would be super interested in
Yeah, and what you said, I'm also a hockey fan, so I just want to poke a little fun at a coach. That sounds like a coach that doesn't like to skate a lot for me.
it. Yeah.
No, the so that's funny because I co-directed and co-founded a adaptive hockey program for wounded, ill, and injured
That's right. Yeah,
veterans.
yeah, yeah. We were talking about that. Yeah.
Yeah, and so we played adaptive hockey on sleds. So these are people that normally are amputees or even paralyzed or have significant disabilities where they're wheelchair bound, or even guys that are mobile but have lost their ability to play stand up hockey. Then they're allowed to contribute, and it's full contact, full checking, and it's pretty amazing. But that I could definitely see because that was fetching cones and moving cones around for a drill when you're in a sled and you don't have a stand-up volunteer or coach to help you do that, or even fetch pucks. I mean, that would be awesome. I could imagine touching a button on an app and the cones just move themselves on the ice.
Right. Yeah. And even the fact that a lot of the people that are coaching like youth hockey, they're just a
Yeah,
parent. They've never
yeah,
coached before. They don't really know anything about it. So like this is
yeah,
a way to enable them to be very proficient coaches
yeah.
with pre-made drills. So yeah, I probably shouldn't have shared his.
No, no, yeah. Put them in touch. We can talk about prototype because one of the other things I absolutely love and I'm passionate about is entrepreneurship as a whole. I love to
Yep.
see people get out there and put themselves out there and go through this process. And what people don't realize is how much free money is out there for you to encourage you and incentivize you to do this. There's more than people realize, and this at this point in time, there's more than has ever been in history. There's more non-dilutive capital opportunities. There's more specific focus in specific technologies as well as specific founder bases, specific demographic backgrounds, and more opportunities for those disadvantaged amongst our community as well, where people are recognizing that, hey, if we give a focus on them as well, we can help uplift them because all tides rise, the rising tide rises all boats. And as well as ones for our community as veterans, which there are fabulous ones. As a matter of fact, I had the great opportunity to pitch in front of one on Monday here in Boston, put on by an organization called InnoVets, which was through the Mass Fallen Heroes Foundation, which is a fantastic organization I'm familiar with in Boston. And I got to pitch, and unfortunately, we weren't a finalist, but you got to celebrate the losses because you can't win them all. But I've won over $90,000 in non-dilutive capital from these competitions and from these projects, including being a top 10 finalist in the Army X Tech competition, which allowed me to pitch in front of like such huge names and be recognized and seen by all these I think as a result of that conference, I came away with three prepaid pre-sales from, I think by the end of that one, Boeing, Northrop, and um, who else was it? There was one other one that finalized and bought prepaid pre-sales from us. By that, I had a 3-page white paper in my pocket, and we had just replicated the original lab experiment in the kitchen.
Mm, wow. Yeah, well, I mean, that tells you that the idea has legs. I mean, it's definitely, I can certainly see how this is the way of the future. But super exciting, man. I'm excited for you. I can't wait to see what the next couple of years brings, and I'm sure you're going to be successful with your energy and enthusiasm. So, hey, thanks for coming on today and sharing about your product.
No, Nate, thanks for having me, and I love what you're doing, and keep it up. And I would love to see more veteran entrepreneurs and veteran businesses. There's a lot of interesting technologies coming down the pipeline for manufacturing. Advanced manufacturing is got some crazy stuff, as well as additive manufacturing as a whole. Like the metal printers are really dominating the industry as a whole with some groundbreaking things. They printed a rocket, 3D printed a rocket that when in space, the fuel tank of the rocket was 3D printed,
Wow.
and that was 4 years ago.
Wow. Yeah, imagine where they're at
So
now.
yeah, and a matter of fact, one little known fact is look to Google how much of the SpaceX new Raptor rocket is 3D printed. Because of 3D printing and some of these advanced technologies, it's allowing game-changing geometry and features to be done which traditional manufacturing cannot do, including if you look at some of these cool rocket throttles and rocket bells coming out of these engines. They now have integrated airflow channels within the center of two walls of metal with where the features of the walls actually encourage increased airflow or vortexes or other types of processes so they can get the max efficient use of the fuel and the gases that they're pumping through for ignition. And that's the reason
Wow. Yeah, it says
why Elon's been able to go from the Raptor being like and removing so many components and it's still functioning.
40% of it by mass of its part manufactured by 3D printing.
Yeah, and F1 racing, IndyCar racing. I spoke with one of the engineers in one of the garages at an IndyCar event, and he said 41% of the Indy cars are 3D printed, including some of the exhaust manifolds, which are some pretty high temperatures running through
Wow.
there and pretty big pressures.
Yeah.
So but yeah, no, there's lots out there. Deep tech is pretty amazing. And yeah, no, if anybody hears this on the veteran side of things, I got to keep my time limited. So I always love to serve our community. I'm always willing to give some time to veteran entrepreneurs, especially if they've already taken those first steps. Don't come to me if you have a great idea and you haven't
Right.
done any
No,
action.
you're right.
Come to me
Yep.
when you've taken those first steps.
Lots of idea people out there, but yeah, the people that can actually, that next step is the hardest. And
It is, but there's a million ideas, brilliant ideas from people every year. The problem is there's not a million people willing to execute on those
right.
ideas. The
Yep.
most risky situation is taking that first step, and
Yep.
it is difficult and it's scary and it has its challenges, but. And this is where our community is veterans, and why I encourage veterans to do entrepreneurship in any fashion is because we have been built and had our backbone built upon with resilience. We
Right.
know to keep going forward and keep marching on. And sometimes in the gloomiest days of entrepreneurship and building a business, all you have to do is make it to the next day,
Yep.
and
Yeah,
that's all that counts.
yeah, and the risk, and that's the thing too, is like we're pretty comfortable with risk. And for me and you as an entrepreneur, the biggest risk that we could take is not taking a risk and finding out what happens if we didn't, like what did we miss out on by not taking
Yes,
that risk? Like that's terrifying to me. I'd much
the
rather
what
take a
ifs.
risk and lose on it than that. But yeah, it kind of
It,
reminds you of like the infantry motto, which they said uh, movement without fire is ineffective. Fire without movement is suicide. And
yep.
so, it's kind of just you got to take that risk.
And when you do have those great unknowns where you don't know what's going on, it's also in our program and as U.S. military members, default aggressive, become aggressive. That's one
Yep.
thing I do when it hits me at times where I feel like I've lost all my momentum, the wheels are turning and we're not moving anymore. And then what my immediate response is, I need to be more aggressive. Suddenly, I found myself sending out 100 new contacts for leads, trying to generate new sales. I finished three grants in the last 3 weeks, which normally these grants take 6 weeks to write. So, and then as well as being smart and leveraging those tools around you. We can't be all old fogies and set in our ways. We're busting out our old flip phone because we refuse to use a smartphone. If
Right.
you're trying to build a business, you need to jump in with 2 feet with using new technologies, and AI is a game changer in that regard. So um, the two things for our veteran brothers and sisters out there: if you have disability, if you have a retirement check coming in, you have your basic needs met. You're at the perfect position to leverage. And this is how you leverage your service, and what you've done is you leverage your VA disability and your retirement to pay your bills, your immediate bills, so that you can grow a company, get yourself and move your
Yep.
family into a better place.
Yep.
That's one thing that we have over anybody else in our society. Those of us who have those that and that helps you realize that your disability isn't just meant to make you sit somewhere and feel sad for yourself and bad for yourself because your injuries drastically affected your life. I'm 100% disabled. I've got my host of issues, and one things I've tried to do now is I try to be more publicly vocal about those challenges I face and how I'm still overcoming them as an entrepreneur. And if not, I try to leverage some of those same disabilities to assist me as we progress. It gives me a different perspective in how to help others as we move forward, and help those who in our society we have a lot of people that unfortunately are unable to help themselves, not the ones that are unwilling. I'm talking about those that are unable.
Right.
um,
Right.
and
Right.
you know we can do better. We can serve our country. I consider this a second way of serving, because I've not just leveraged my VA disabilities. I've leveraged our DoD's ecosystem, where there's thousands of technologies available for licensing by small business, and there's programs to help you learn how to do it step by
Yep.
step. And then I've taken that and I've leveraged DoD dollars from our taxpayers, grants, and other types of funding opportunity to participate in what I think is the new American dream. And the only difference between this service is I get to help our brothers and sisters in arms and in uniform still with a defense technology, but I also there's a much larger pot of gold at the end of the rainbow with this journey.
Sure. Yeah, no doubt about that. Yep. Well, yeah, I think it's great what you're doing, Ian. Like I said, I think you're going to be successful. I'm really excited for you, and we need to
Thank you.
continue the conversation between us because I have a lot of ideas in my head that I have taken the first step on that I think you might have some advice on. So, thanks for your time today, brother.
Not a problem, Nate. Thank you, brother. And veterans, get off your butt. Time to get back to work.
I
Work
agree.
on yourself. Do
I
better for
agree.
yourself. Your love,
Yep.
your family, your God, whatever your belief systems are. You feel so much better when you're moving forward than when you're just sitting stagnant.
Yep. Quit holding up the wall.
Right?
Or the
Thanks a lot,
bullshit.
Nate. Right? Yeah,
All
got
right.
to remember those of us with those crazy nautical terms, right?
Yes.
Only us sailors and Marines really understand the atrociousness of what e-dunk actually is.
Yeah. So many terms. All right, brother. We'll see you.
All right, take care, Nate.